Well, here you go, boys and girls. This is my triple expansion Stewart engine. This is about a little over 2 years to make. I thought I would start out with a running video showing you the finished engine so that when we talk about the various components, you'll kind of get a rough idea as to where everything kind of is supposed to go. I use my vernier to mark out the positions of the crank journals. It's really critical to get this absolutely as correct as you can. If you don't, then nothing is going to line up with the cylinders and all the related parts above it. This shows the, I guess you would call them the end plugs that I used on the crankshaft. These are spaced 120 degrees apart, and I did those plugs on the rotary table. You've got to get this really right, and you've got to line those holes up with the crank throws so that when you start turning and grinding things, you won't end up with a big mess. I do not believe in trying to turn crank throws on the lathe with a parting tool or any kind of other lathe tool. You run too much of a risk of wrapping the whole thing around the tool post. I did it, and I always have done it on the milling machine with the dividing head, milling the journals about 50 thousandths oversized, and then later going to a grinding operation. I always grind my crank journals. It's so much better. You can get it right to the thousandth. You can see here the end plugs, how they work. I ground the journals 2 thousandths of an inch under 3/8, and then when I did the rods, I reamed the rods 3/8. 2 thousandths gives a nice clearance. Here we're back on the milling machine, and after I had affixed the counterweights to the crankshaft, I milled all the counterweights, and although it doesn't show it here, I returned to the lathe later and ground the outside of the counterweights. It's a lot better to do this than to try to turn it. That crankshaft is very spindly, and if you get a tool caught at this point in time, you're going to want to kill yourself. So back to the tool post grinder to be on the safe side. Here's something I forgot to mention when I showed the video of the grinding of the crankshafts. Do not use a live center. Use a dead center and adjust it very carefully so that you don't put torque on the crankshaft and squeeze it and distort it and then grind it, and then when it springs back, it's a mess. Use dead centers. Do not use a live center. This is the start of the connecting rod. I started out with a square chunk, and you can see the progression. This is basically a combination of milling machine and turning between centers on the lathe. You can see how you start to whittle this thing down. By the time you're done, there's 90% chips on this as opposed to what you started with. This is the completed connecting rod with the brass ends. Well, when you get to this point, you're going to feel pretty good about yourself if you haven't messed up. You can see here, this is the finished crankshaft with the connecting rods and all their related little pieces. And when I got to this point, I felt pretty spunky. And you can see here that by the way I carefully ground the crankshaft and reamed the connecting rods, that they fit properly and they fall at their own weight. There's no binding, and I felt pretty darn good at this point in time. This is the crosshead, and this was a real tricky part to make. I didn't take a lot of pictures of it, but you can kind of see the approach that I took to it. I think I've got another picture coming up on it. It shows kind of the way I worked it on the lathe. Yeah, here's the other piece that bolts to it, and then I had to start doing some more milling. You do a lot of cutting up on that piece. I should have taken more pictures. Sorry about that, guys. Well, here's working the bed plate, and I don't have to tell you at all how critical this thing is, because everything works from the bed plate. When I did all of the drilling for the holes on the bed plate, I started in the upper right hand corner for where one of the columns goes, and I kept referencing off of that hole for everything else. I would suggest you use a pointer or a wiggler or something and prove this thing out, because the casting is a little off, especially on the 3 holes that go for the the water feed pump. Be careful with this, and when you do it, take a lot of notes as to what your positioning was. I do not have a DRO, so I had to make a lot of notes as to how I did it, because that has to be translated to other parts above it, and mainly the block and the guide rails. So be very careful with this. Think it through before you get nutty here. These are the main bearings. It's pretty straightforward. Nothing you probably haven't done before. A milling machine, lathe, you can do it in any orientation and any order in which you want to do it. I individually fit them to each spot in the bed plate. Well, now you can start to do some assembly. This is going to make you feel real good once you get to this point, especially when you start putting the crankshaft is in place. And as you can see in the video, it turns nice and freely. I made sure that I usually use 2/1000ths of an inch clearance on the journals of the main and the main bearings. So you can see it's turning real easy with my fingertips. It's not binding up. So yeah, you're feeling real good at this point in time. At least I was. Good. Well, here we are doing the eccentrics. There's 3 of them. 2 of them, they're all different. One is split, and that's a real trick to do. You're going to have to think about that one for a while. I didn't take a lot of pictures of it. Sorry, boys and girls. I just didn't do it. You can see the end blocks that I used to get the offsets, and you'll see the end block in the next picture. This is probably who knows which one, but you'll have to think about this. Look at the drawings on the plans. You're going to have to make 2 different ones, I believe. This is working on the eccentric yokes. I did some pre-machining on this, and then I reamed a center hole. And you notice at this point in time they're not split. That's a good reason. I reamed it at a standard size. And then I put it on a mandrel and faced it. Now, this gets a little tricky, so bear with me on this. This shows the facing of it, and here's where I marked where you have to cut all the little slots for the arms that go above it to the reversing yoke. Now here, it's not split yet, but I drilled the hole, or the tap drill size, all the way through. And then I split it. And the hole is still undersized. At this point, you can put it back in the 4-jaw chuck. You'll have to use a 4-jaw and bore the yoke out to final size and groove it to fit the eccentric. Notice the little etchings on the yoke. Everything is individual. Please keep everything marked so you don't mix up one yoke with another yoke, tops to bottom, etc., etc. You know how bad that can be. Well, I set my milling machine up on an angle, tilted the head, used my tilt table, and went through a lot of trouble because I wanted to put the set screw, and in this case I used 3 set screws. This was a hell of a setup. I did not want to put a set screw in the face of the flywheel, so I went through this kind of trouble. I spot faced 3 places on the flywheel, and turned the rotary table again, drilled and tapped it. I was kind of anal about this, but I just didn't want to see a hole in the face of the flywheel. So if you want to go through this kind of trouble, well, go for it. You're probably just as stubborn as I am. This shows milling the quadrant for the reversing link. I didn't take a lot of pictures here, probably should have. It's done on the rotary table. Well, here we see the eccentric, the yokes, some of the arms and links all put together. This shows a considerable amount of work. This shows a lot of the linkage. This is the reversing shaft operating lever. This is a little tricky part to make. You have to really think about it. There's offsets to it. You start out with a relatively large piece of material and keep chopping away at it on the lathe and the milling machine. The good part about making these links is the fact that you're making them out of basic bar stock, and if you screw it up, you can just trash it and start over. This is the guide bar bracket, and it's a relatively easy piece to machine, but if you remember what I said earlier, make notations as to your dials or whatever you did when you did the bed plate, because those 4 vertical holes have to absolutely line up with the bed plate or you will have a mess. Also, the 3 holes that are tapped 348, the spacing on those, majorly critical, because they have to line up with the crosshead and the cylinders. So you gotta think about that also. This is a critical piece. Any screw up here, you're gonna have binding majorly. This is the rough casting for the reversing shaft bracket. It looks like a real easy thing to do. However, once you really get involved in it, not so. Well, this is the finished reversing shaft bracket, which goes on one side of the support columns, And please note that those support columns are different sized. You can screw that up real easy. Anyway, on these guys, they're really tiny little pieces, but they've got to be done quite accurately. Respect to the vertical hole, and then the horizontal hole distance has to be the same. If you get that goofed up, then your reversing shaft is going to bind. You really got to think about this. I didn't take a lot of pictures, but there's a lot of sequential operations to do it. You go from the lathe to the milling machine to this to that. You'll eventually figure it out. It's not bad, but take your time with it and think about it. But have fun with this one. Well, here we go doing the block. I've already milled top and bottom, and I milled a little bit off the top and then flipped it, milled a little bit off the bottom, and then flipped it in the middle of this, and I got it where I wanted it. Don't take everything off of one side at one time, because you have to look at your exhaust and intake ports. You don't want to cut too much off one side. Trim a little bit, trim a little bit, trim a little bit until you get it to final size. Be careful about that. Once again, you're going to be working off center line, and whatever you did on the bed plate, I started in the upper right hand corner and I worked my way across everything. And you're going to use those same dimensions that you took really good notes on, and I'm sure you took good notes. And then you can go ahead and basically the block is pretty easy. You just have to make sure you line everything up with the bed plate. Here you can see boring the cylinders. Remember, everything works off the center line. However, in my case, I started at the back right-hand hole and indicated all measurements from that. Well, here I'm really guilty about not taking pictures. This is the air pump and the water feed pump. They're kind of tricky, but they're also a lot of fun. There's a lot of internal parts on the air pump. You're going to have to figure this one out. I didn't do a pictorial. The only thing I can say is on the water feed pump, I ended up cutting it all apart and using nipples and pieces to hold it back together. The casting was poorly aligned and it was almost impossible to machine it to my satisfaction. So I cut it apart and just did it that way. You can look at the video or the final assembly pictures and you can see what I did with this. To me, it was the simple solution. These are all the pump rod glands. You can see kind of what I did. I kind of machined it on a mandrel, and then later on you can see I went to the milling machine. These are the valve rod glands. They're all pretty basic. I didn't take pictures of how I did it. Well, I do, but I'll talk about it when we get to that. This is the bottom of the cylinder, and this is really a tricky part to do. You have to be very careful about it. What I'm milling here is the one vertical edge that holds the guide bar that the crosshead travels on, and that edge has to line up with the guide bar at the bottom. So you're going to have to do a lot of mathematical calculations as to determine parallelism between everything. The crosshead, the piston rod. I used the rotary table and did a lot of calculations on the angles for the various packings. Two sides are milled parallel. You'll have to think about where your center line is. It's the only really way to make it look decent. You could file it by hand, but it looks like garbage. This is the correct way to do it. This shows some finishing up work on the block. Nothing much to be said here. You're going to think about how you're doing it. This is just another picture of doing some work on the valve packings. They're different sizes, some are different angles. You're just going to have to go for it yourself. This shows one of the valve packings going into the steam chest. What I did here is put it together and then drilled and threaded the packing into the casting, and then milled the packing and the casting together as one piece. Really turned out slick. In the upper right hand corner you can see the steam packing and the valve chest machined together, and it really makes a nice presentation. And then after the steam chest was attached to the main cylinder block, I milled the two even. Here I use my wiggler to set up the steam chest and mill that, or machine that top little dome. It's the only way I could figure out how to get it centered up. Here I was doing some test assemblies, taking pictures of parts before they, or as I was putting it together. I did this so it gives you kind of an idea how the assembly goes. Some of this can be complicated. Some of these pictures might be helpful. So now this is before I sent all the parts out to have them nickel plated. And then this is what it looked like when it was assembled. I decided to have everything nickel plated. It was a pill to mark everything, and it was a pill putting it back together after I got it back from the nickel platers a month later. But it was worth it. The nickel plating really makes everything pop, and you take it for what it's worth. It's a good little project. I made the base out of walnut, and here it is running again.